Okay, good morning once again. You're on to Mamu with Jarvis. Mamu stands for the Mathematics Multiverse. And you'll notice that on my board is written further mathematics, pure maths, and we'll be looking at the matter of binary operations. Just to get us used to the setup, because subsequently you may only be saying pure maths as a subtopic or as a main topic rather, and then other topics to follow. This aspect we're going to be treating this morning is very, very crucial. The matter of binary operations. When we mention binary operations, what comes to our mind? Look at binary, look at the word operations. Two things come to mind. Binary will suggest that you are talking about two things, and operations will suggest that you're dealing with some rules to help you take care of problems. So if I put that together, a simple definition to the matter of binary operations or binary operation is talking about rules of combining two terms or sets, understanding what the behavioral outcome would look like. So that's big grammar. Let's keep it very simple. If, for instance, I go back to my primary school, I see 1 plus 2. The rule for combination says what? Add 1 plus 2. So these are the terms or the numbers or the items or the elements, depends on what you choose to call it, or even the sets. And what is combining them is what? Addition. So 1 plus 2 will give me 3. Means to 1, add 2 to it. Now we can also have 3 minus 1. 3 minus 1 will suggest to 3, move 1 out of it, and that will be what? 2. We can also have what? 4 times 2, and that will give us what? 8. And we can also have 4, same 4 divided by 2, which will mean 4 over 2. Split 4 to 2 parts, and that will be 2. All of these itemized here are essentially called operators. They are called operators, and in mathematics, we call them mathematical operators. To be very at its fundamental level, we can call them arithmetic operators, because what they help you to do is to carry out basic arithmetic operations like addition, subtraction, multiplication, and division. So these are basic. We can also stretch the thought to something like set. If I say A intersection B, for instance, now I'm going to a higher level of teaching now. And let's say I say A is a set of 1, 2, 3. And I say B is a set of 2, 4, 5. Now, A intersection B, A operated on B would imply that I'm concerned with elements that are common to A and B. And that answer will simply be what? 2. So the concept of binary operation refers to relating terms or relating sets by understanding what is instruction that problem should carry out. It is also very important to note that when we talk about binary operation or binary operations, there is an aspect of maths that also comes to mind. It is a matter of sets. And that's where I tease that here, matter of sets. What's a set? A set is simply a collection of what? Elements, items, numbers, objects, description of certain group of things by giving name. Now, beyond that, when we treat binary operations, we are concerned about the elements, relationship between the elements, such that the set under consideration is a non-empty set. If you've done sets, you will discover that there is a type of set we call the empty set, or some we call the null set, which we generally represent by this showing that there's nothing in it, or we represent by this. Now, we're saying that the set we're using to work must be a set such that the set is not empty. In the course of the course, we would explain in details why this must be a necessary condition. Having said that, let's come back a little to look at something that is also very crucial in understanding the matter of binary operations. I have watched with amusement and somewhat horror that students find it very difficult to understand this topic, binary operation. But for me, it comes so easy because I'm trying to figure out why it's so difficult. And it took me 4 years to figure out a certain reason why this topic seems very abstract. Because more often than not, teachers take this topic without driving students or bringing students' heart to a very simple primary school concept. And that's where we're going to build from. Because this concept is also a set. This concept is also what? A set. What is this concept? It's a simple concept we call what? Numbers. In your grade 7, you'll be treated to the matter of number systems and different types of representation of numbers and the likes. But students have failed to understand that this simple idea is the driving force of all understanding when it comes to the matter of binary operation and maths, to say the least. Okay, so with that said, let's look at numbers. What is a number? A number is simply the representation of what? Quantity. A number tells us how big or how small. So what then is a number? A number simply talks about the symbol or the representation of quantity or value. Quantity or value. So mathematicians seem to come to a compromise on the fact that we have 5 types of numbers. 5 types of numbers can easily be recognized. I'm going to list them on the board. And this is not the course for this. I've done lots of videos. If you go to my playlist, I think that should be grade 8 and grade 8 or grade 10, if I'm right. I've done extensive work on the types of numbers. So, but this is just more like to help you come into terms with what we're going into. Because if you don't understand numbers, you would find it very difficult to flow with this concept. So we will not be too expansive today. We'll just take it very light, and I'll trust that you go back to my channel after post to see how you can understand this concept better. Now, what are the types of numbers you have? 5 of them. The first one we call natural numbers. The second one we call integers. Integers, or what you may call directed numbers. The third one we call rational numbers. The fourth one we call irrational numbers. And the fifth one we call complex numbers. So to drive home my point, I'm going to wipe this part of my board because I'll need to stretch out the concept. And this is where I'm going to wrap it up. I wouldn't go beyond this today so that you have a clear understanding of what we're going to be doing. Now, these first two are what we call whole numbers. These next two are the ones we call decimals. Now, although I call this decimal, we call this one, this decimal type can either be recurring or terminating. I'll go through my playlist and figure out the videos which I've done extensive work on this. I won't want to go extensively into this. That's the reason I'm going to be stopping early so that you can go back, watch this video, and have a feel of what this is talking about. I'm going to drop the link so you can watch this video, and then when we come in to do the binary operation work, you will begin to understand clearly what we mean. Now, this is the one we call non-recurring and terminating. So it's not recurring, it's not terminating. It's not recurring, it's not terminating. Now, we also have now, all of these four come under what is called real numbers, because you're going to be hearing a lot about numbers. We're talking about sets. Now, in the context of binary, when we talk about a set, we refer to numbers, the description of number types. We're looking at number types. So when you hear sets in binary, what we're talking about is number. A number is defined under, by my next class, you begin to see letters like Z, N, and the likes, but I don't want to throw those ones here today. So when you hear a set is defined under real numbers, it means that the description, the band, or the quantity of numbers you're going to be working with are so much. Now, so we've established a simple thought that anytime you hear the word set as it pertains to this topic, we're essentially talking about what? The type of number or the number category under consideration. Now, let's look at complex. Now, we're talking about complex numbers. We're referring to numbers that are both real and what? Imaginary. But essentially, the matter of complex essentially refer to imaginary. So a number is said to be complex if it has only an imaginary part or has both imaginary and real. If that number is only real, it is not complex. Hear this, and essentially we'll be coming into the concept of I. I won't go deep into this because this is really not your what we call your secondary school level mathematics, but you should know, for those of us who will be planning to go into courses like engineering, you should know engineering, computer science, and the like. You should know that there is a fifth type of number, which we call complex. Other mathematicians will come up with different classifications or whatever, but I've used this model for years to make things very, very simple for us. The 5 types of numbers, natural, integers, making up whole numbers. We have rational and irrational, making up decimals. And we have complex numbers, which must have an imaginary part and or a real part. So when we go into binary operations, you'll be hearing things like real numbers, integers. Sometimes they use letters. It's important you understand where they are going to. So we'll just keep it simple today. We've done an introduction to the topic, binary operations, and we said that it's a relationship on relating to the rules relating to elements of a non-zero set. And when we talk about the sets here, I'll reiterate and say that the set we're talking about here is what? The set of numbers. Essentially, the topic binary operation refer to what? Relationship with what? Numbers. And we started by trying to look at basic mathematical operations. So you see that every time you say 1 plus 2, 2 plus 3, 4 plus 4, and the likes, what you are talking about is what? Binary operations. I hope I have helped you this morning to whet your appetite into the matter of binary operations. And I will trust and believe that in our next meeting, we'll go deep into this topic. Don't forget to subscribe. Don't forget to like. And this is what we are doing and we will keep doing. See you in my next class.